Hello everyone, my name is Devipya Sai. I am from CSC G section and my roll number is 24BQ1A051G. Today I am going to discuss about breadth first search traversal. Traversal to visit each node in the graph. Exactly once is called traversal. Graph traversal is of two types. Depth first search, it is represented by stag, and breadth first search, it is represented by cube. So queues in breadth first search. Define a queue size is equal to the total number of vertices in a graph. Here is a graph with 7 vertices. So adjacent vertices of A are B, D, E. Adjacent vertices of B are A, C, E. Adjacent vertices of C are B, E, F. Adjacent vertices of D are A, E. Adjacent vertices of E are A, B, C, D, F. Adjacent vertices of F are C, G. Adjacent vertices of G are C, F. So here we given queue size is equal to 7. Select any starting point vertex. It must be a non-visited vertex. So here we selected A. Visit all the non-visited adjacent vertices of the vertex A, which is the front of the queue, and insert all the non-visited adjacent vertices B, D, E. Delete the front element A from the queue. So after deleting the front element A from the queue elements are B, D, E. Now visit all the non-visited adjacent vertices of the vertex B, which is the front of the queue, and insert all the non-visited adjacent vertices, that is C. Delete the front element B from the queue. After deleting the B from the queue elements are D, E, C. Now visit all the non-visited adjacent vertices of the vertex D, which is the front of the queue, and insert all the non-visited adjacent vertices. So there is no non-visited adjacent vertices of the vertex D. Now delete the front element D from the queue. After deleting the front element, the queue elements are E, C. Now visit all the non-visited adjacent vertices of the vertex E, which is the front of the queue, and insert all the non-visited adjacent vertices F. Delete the front element E from the queue. So after deleting the front element E from the queue elements are C, F. So visit all the non-visited adjacent vertices of the vertex C, which is the front of the queue, and insert all the non-visited adjacent vertex F. Delete the front element C from the queue. After deleting the front element C from the queue, now the queue elements are F, G. Now visit all the non-visited adjacent vertices of the vertex F, which is the front of the queue, and insert all the non-visited adjacent vertex. So there is no non-visited adjacent vertex of for the F. Delete the front element F from the queue. So the queue elements are G. So visit all the non-visited adjacent vertices of G. So there is no non-visited adjacent vertices of the G, and delete G, and the queue is empty and the graph is completed.